We're just going to keep doing more and more derivatives. Practice, practice, practice. Tons and tons of derivatives. Let's do another one. Here's 4C. G of Z. Yep, that's right. We're practicing lots of different variables. 6 cube roots of Z. Now tell me things. Yes, as soon as you see that radical, what are you doing? Yeah, you guys are so good. Change that to an exponent. As soon as you see a radical, change to an exponent. As soon as you see that radical, change it to an exponent, then do work. Because 98% of success in mathematics is what? Organization. Good. So, have that organization. Rewrite it. Don't try to do this stuff in your head. Nobody's giving you an award for that. Write it down. And then do work so you don't make any mistakes. Oh, for the love of Pete. Oh, I almost made a mistake, but I didn't. We're good. We're good. Bring that in front is 6 times 1/3. And then remember, I am subtracting 1 from this, but when you have that common denominator, that's going to give you a negative 2/3. 3 goes into 6 2 times. So G prime of Z is 2Z to the negative 2/3. Just leave it as an exponent in your final answer, because that will help you going forward. There's no need to try to change that back to a radical, put it in the denominator. There's no need for that. Leave it as an exponent because we can work with exponents. You start trying to change it up, then it makes it to where we can't work with it as well. Okay, let's do another one. I told you we're going to practice, and practice some more. Take some derivatives. That's how we get good at them. 3x to the 5 halves over 2x squared plus 4. All right. Can I algebra first on anything with this? No. There's that plus sign in the denominator. This is not a monomial. So this has to stay together. I can't break that up. So then I have a function divided by a function. Yep. We get to do the quotient rule. Good. The derivative of the top. So 3 times 5 halves. Subtract 2 over 2 from that, and then you get 3 halves times the bottom minus the top times the derivative of the bottom, which is just 4x, right? That's a constant. 2 comes in front, all over the denominator squared. Good. Now we have fractional exponents. That's okay. We have fractional exponents. There is nothing wrong with that. But when you have like bases, you add those. So this is the same thing as 15 halves, right? So we'll distribute. Oh, these are just multiplied over there. Okay. That makes our life even easier. So 15 halves times 2 is just 15. Your like bases, 3 halves times 2. If you get that common denominator, that would be 4 halves. So I have x to the 7 halves. Plus 2 goes into 4 2 times. So 2 times 15 would be 30. And then x to the 3 halves. Do you see what just happened there? Do I need to go through that one again? I usually do. All right, let's come down here off to the side. I've got 15x to the 3 halves times 2x squared, right? Ooh, pardon me, 15 halves. So then this 2 cancels out that 2. I have like bases. This changes to a 4 halves. Then 15x to the 7 halves. That's where that came from. Do you see that? Okay, then I have 15 halves x to the 3 halves times 4. This 2 cancels out that 4 and makes it a 2. So 2 times 15 is the 30, and then there's no variable, so I just have x to the 3 halves. Okay, And then the same thing's happening over here. This is an exponent of 1. So I now have minus 12x to the 7/2 because it's adding all over the denominator squared. Ooh, okay, okay. Now I've got some common terms here, folks. So f prime of x is now going to be 3x to the 7/2 plus 30x to the 3/2 all over 2x squared plus 4 squared. Now you can factor out that numerator, but it's obvious that the top and the bottom, there's nothing you can do to cancel out. So you are welcome to keep it here. Or if you do some factoring, then you have f prime of x. If you factor out a 3, remember, we did factoring from the beginning. There's a reason for it. Factor out that lowest exponent. And now I'm left with, I factored out my 3. Remember, when you factor, you subtract because it's dividing. So if I subtract out the 3/2, I'm just left with x squared in there. And then 30 divided by 3 is a 10, and then my exponent is good. Down here even, you could factor out a 2 and square it, so you could get this 4. And then you've got x squared plus 2 squared. I don't care if you pull that 4 out or not, or if you just leave it in there. Did you see what I did there? This is the same thing as 2 times x squared plus 2. That whole thing is squared. And then you can take this 2 squared, so 4. X squared plus 2 squared. I don't care. Either way, on that kind of situation. Now, the numerator, again, is nice to factor out because when we start trying to find critical values, it's easier to find critical values if that's factored out. All right? But it doesn't have to be. All right. Let's do one more, and then we'll call it for this section. Do one more practice here. Here's example 6. Find the derivative, of course. Y is equal to 4x times 2x cubed minus 3x to the negative 1 all over x squared plus 1. Now, I'm not going to go try to be doing some product rule within a quotient rule. That's crazy talk. You got a monomial in front. Take care of business. Yeah, algebra first. 8x to the 4th minus 12, period, minus 12. Because whenever I add like bases, this x and this x to the negative 1, those cancel. That's sweet. All over my denominator. Now there's really nothing I can do to simplify that down anymore. So now we do the quotient rule. Derivative, pardon me, the derivative of the top is 32x cubed times the bottom minus the top, 8x to the 4th minus 12. I know is going to happen because look how sweet this one is, just a little 2x, right? All over the denominator squared. Now clean it up some. Y prime is equal to 32x to the 5th plus 32x cubed minus 16x to the 5th plus a 24x all over the denominator. I've got like terms with the fifths at least. So y prime is going to be a 16x to the 5th plus 32x cubed plus a 24x all over the denominator. And again, we know there's nothing you can do there, but moving forward, it is nice to factor. So you can factor out an 8x, and I'm left with 2x to the 4th plus a 4x squared plus 3. It's just nice to look at it like that. Because then it's factored down and I can see what it is that I have. All right. Practice, practice, practice. These derivative rules, we're just going to keep adding to them and adding to them and adding to them. They are so, so, so important. So important. You have to know these processes just like your breathing, because it's going to take you for the rest of your math career. All right. Great job, guys. Go practice.